On behalf of 24houranswers.com, I welcome you to today's lesson. In this video, we're going to look at a third example involving perimeter and area of a rectangle with optimization. We have seen two other examples about John and 100 feet of fencing. We've done this example here and then this one back here. Here's the new part for this problem. John still has 100 feet of fence. He wants to make a pen for his dogs. He's going to use the back of his house as one of the sides of the rectangle. However, John needs to separate the males from the females. What is the maximum area of the entire dog pen with both sections combined? So the main difference in this one is that I have this additional piece of fence here, and we're going to need to put some fence here, 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 and one all the way across. Now you don't have to label it this way, but I'm going to do x plus x plus x plus y is going to be the entire 100 feet of fencing. Again, John is using the back of his house for one side of this rectangle. Therefore, the perimeter, if you will, or the amount of fence is going to be 3x's plus that longer side y is equal to 100. The area of the entire dog pen is still going to be x times y. Let's look at this. Even though we have two sections, this one here and this one here, the area of the entire dog pen is still going to be a length times a width, x times y. Very similar now to the previous two examples. Let's get a variable by itself. It is best to get y by itself here. Y is equal to negative 3x plus 100. Let's substitute all of that stuff into this y. Therefore, we'll have area in terms of x. And again, the reason why I'm doing this is that we are trying to maximize the area, so the area function is what we want to take the derivative of. Therefore, when we take negative 3x plus 100, substituting that into y right here, and then we distribute, this is our formula for area. Let's differentiate this and let's set it equal to 0. And ultimately, what we're going to be finding here is a maximum, again, because we have a parabola, we have a quadratic, its leading coefficient is negative, guaranteed to have a max. Taking our derivative, we have negative 6x right here plus 100. And now let's set the derivative equal to 0. So we can take the negative 6x, move it over here to this side, making it positive, and then let's divide by that 6. Simplifying that down, we get x is equal to 50 over 3, which is approximately 16.7 feet. Now, I'm not going to round this, even though 50 divided by 3 is right around 16.7. I'm going to use 50 over 3 feet for my value of x so that I can find y. So therefore, we have y equals negative 3 times our x, which is 50 over 3, and then we're going to add 100 to that. And when you do this, you'll get a y value of exactly 50 feet. And now going back to our original question, what is the maximum area of the entire dog pen? So the area was x times y, so we take that x value, 50 over 3, multiply it by 50, and we'll get an approximate area of 833.3 square feet. Or if you just wanted to round to the nearest square foot, I'm sure you would be fine there. Just pay attention and make sure you do round correctly based on what the question asked you. And there you have it, a third and final example of perimeter and area of a rectangle involving optimization. And that's it for this video. I hope it helped. Be sure to check out our YouTube channel for more videos. Links to our social media are in the description below.